Now that we have an unrolled example of the input and output of the network, let's go another level deeper and look at some of the parameters of the model. So at this point of the course, you know that you can't just feed words directly to the network. We need to turn the words into vectors first. This is the same concept we saw in Word2Vec and the sentiment analysis RNN lessons. Our first set of parameters are the weights that we multiply the input vectors by every time we take an element. Now, here's the thing. So you don't have to worry about this as much. So TensorFlow actually shields you from a lot of this and hides, takes care of a lot of these different parts for you. So don't worry about implementation for now. Just make sure you're comfortable with the general concept, and then we'll get to implementation later. But this is one of the things that TensorFlow handles for us. But it's good nonetheless to understand. So we have U, which is the input weight matrix of weights that we multiply the inputs with, and then we have A, which we multiply the hidden state as it travels between time steps of the encoder and also out to the decoder. We also have another matrix of weights called V that we multiply the hidden state when the decoder outputs its values, and another one called B that goes when the hidden state, that's multiplied by the hidden state when it travels between decoder time steps. The last major component of such a model is a fully connected layer at the output to translate the state of the network into an output we can choose. So these would be the output logits. The number of these logits is the same as the size of our vocabulary. The logit with the highest value corresponds to the word that the model wants to output. So we'll take an example. We'll clarify all of this. So let's look at this simple vocabulary. So if we only have that one example of input and output, how are you? I am good. We will have a vocabulary of size 11. Never mind the first 4. So these are set. These will be useful later. So we reserve the first 4 spots in the vocabulary for pad, for EOS, which is end of sentence, UNK is unknown, and then we also go. So we've seen go in some of these, but we'll get to that later in the implementation stage. So, and then we have the list of our words that we actually use in our training data. So this is our vocabulary. It has 11 elements. And so at each time step at the decoder, the output of this network will tell us which element is most likely to be generated based on the training data. So this is a small example. So we have a small vocabulary. In real data sets, you'll come across vocabularies of tens of thousands usually of examples. So you'll have tens of thousands of logits in that last layer of the network. So luckily, this is probably the last time you'll have to look at this view of the network. TensorFlow defines an API for sequence to sequence that hides away a lot of these details. And you just have to use its API to define how you want the network to work.